ASRA Phase 2 is Object-Centric Adaptive Reasoning, the shift from pixel transitions to symbolic structure. Phase 1 established that interactive intelligence can begin with transition evidence alone, log state changes, infer course action semantics from cell-level diffs, and explore under uncertainty. That foundation is necessary but not sufficient. Human-like reasoning over grid worlds operates on objects, relations, and transformations, not raw pixel arrays. Phase 2 is the observation engine. Segment grids into connected objects, detect transforms, and induce rule candidates. This video walks through the theory article, the Kaggle notebook, and every ARC AGI3 testing gate. ASRA's roadmap stacks competencies. Phase 1 is the experience engine, transitions, hashes, cell diffs, exploratory policy. Phase 2 is the observation engine, objects, regions, transforms, rule hypotheses. Phase 1 answers, what happened to the grid when we acted? Phase 2 answers, what structural entities changed, and what operator class describes that change? Without Phase 2, semantics inference collapses to coarse buckets. No localized update, multi-cell change, that cannot distinguish rotating a component from creating a new one. Phase 2 is the symbolization layer that makes later causal and strategic reasoning tractable. Integer arc grids use a small color palette. Phase 2 adopts connected components. Pixels of equal non-background color form objects. Background is the modal color. Each object carries object ID, color, area, bounding box, centroid, and a rotation invariant shape hash. This is deliberately minimal, interpretable structure for differencing and rule templates, not heavy vision models. In interactive loops, compact scenes store counts, boxes, centroids, and hashes only, attached to transition metadata when object hints are enabled. Given scenes before and after, a shape matcher aligns objects by normalized signatures under rotation and reflection. Unmatched objects yield delete or create events. Matched pairs classify as identity, recolor, translate, rotate, or reflect. A pair summary aggregates the event multiset. For example, 12 events: create, delete, rotate. This bridges geometry to language-ready tokens for rule induction. The baseline detector is heuristic. Recolor and reflection may collapse into rotate when shape hashes align. Phase 2 metrics measure perception coverage, not solve rate. From per-demo transform detections, the rule candidate generator proposes templates. When every demo shares the same transform types, emit apply types to matched objects with confidence 1.0. When demos diverge, about 2% of 800 original ARC tasks, emit branched per demo plus per demo rules. This turns inconsistency into structure instead of noise. High confidence means internal consistency of the heuristic template across demos, not correctness on hidden test outputs. Batch evaluation shows 100% rule candidate coverage on all 800 tasks. The Phase 2 stack in ASRA ARC decomposes cleanly. ARC loader reads task JSON. Object extractor segments grids. Region detector annotates background and content bounds. Shape matcher aligns cross-scene objects. Transformation detector produces typed events. Rule candidate generator ranks hypotheses. Before-after analyzer produces end-to-end task reports. Offline batch path iterates tasks and writes JSON reports. Interactive path computes compact scenes on each log transition and feeds object effect statistics into exploration scoring. Phase 2 closes the loop with Phase 1 through structural action semantics. The action semantics inferencer now tracks delta num objects per transition. The explorer maintains object effect scores, a structural bonus for actions that historically altered object count. Reasoning strings exposed to the environment cite object count. For example, objects equals 7, making traces auditable. This is soft integration. Phase 2 hints steer search without replacing transition logging or hash-based state keys. The Kaggle Notebook ASRA Phase 2 ARC Prize 2026. IPIN submits agent tag ASRA v0.4 Phase 2 to ARC Prize 2026. Section 0 bootstraps a dedicated venv and mirrors competition wheels. On Kaggle the venv lives in /temp/ASRA_venv to avoid output quota limits. Section 1 writes myAgent.py with embedded compact object perception mirroring the library. Section 2 runs a smoke test with venv Python and -- self-test, simulating what Kaggle scoring does. Section 3 writes submission.parquet as a validation gate. Swarm is not run in the notebook. Kaggle executes myAgent during scoring. Before any Kaggle submit, Phase 2 validates through a layered test gate. Notebook Bootstrap verifies competition assets and wheel install into the venv perception_self_test checks compact scene extraction and object delta on a toy grid myAgent.py -- self-test confirms runtime. Agent class. And venv reexec submission.parquet validates the output schema with agent tag ASRA v0.4 Phase 2. Library tests in ASRA arc cover objects, shapes, transforms, and branched rules. Finally, Kaggle scoring runs Swarm, collects the scorecard, and writes the final parquet. Watch the bootstrap animation. The notebook resolves comp root from Kaggle input paths or local private competition data. It locates arc_agi_3_ wheels and environment files. A venv is created with system site packages. Wheels installed via pip target into site packages. Environment variables set operation mode to competition. Recordings dir, environments dir, and ASRA agents root. Import rsengine and arc_agi confirms the runtime is ready. This mirrors exactly what scoring expects. The embedded perception self-test runs inside myAgent.py. A 3x3 grid with a vertical bar of color 1 yields at least one object in compact scene. An empty grid after produces delta num objects less than or equal to 0 compact scene returns grid shape, background color, num objects, and per object boxes and centroids object delta compares before and after counts. Assertions pass and the test prints perception self-test OK. The notebook smoke test executes Python myAgent.py -- self-test using the venv interpreter. Output shows compact scene objects equals 1. Perception self-test OK. The venv Python path. And runtime self-test OK Phase 2. It also asserts ASRA agent has choose action. This simulates Kaggle scoring before submit. If this fails, the competition run will fail too. The validation gate writes submission.parquet with required columns. Game ID, score, levels completed, actions, completed, and agent. The agent field must be ASRA v0.4 Phase 2. A placeholder row is written in the notebook. After swarm scoring, scorecard to rows replaces it with per game best runs. Notebook outputs are myAgent.py and submission.parquet. Nothing else required in working directory. The ASRA arc library has comprehensive perception tests animated here. Test extract single object confirms one red cell. Test extract multiple objects finds 3 components. Test extract L shape connected merges 4 pixels into one object. Shape tests verify identical similarity and translation matching above 0.85. Transform tests detect translate and create events. Rule tests confirm unanimous rotate yields apply rotate at confidence 1, while mixed demos emit branched per demo as the top rule. All pass. At Kaggle score time, myAgent bootstraps, registers ASRA agent in available agents, and constructs swarm over all arcade environments. Each step, choose action reads the grid, builds compact scene, and scores actions with object hint weight 0.35 take action logs transitions with object scene before and after plus delta num objects. When done, scorecard to rows builds the data frame and writes submission parquet saves results. The Phase 2 agent explores ArcAGI3 with richer observations. Same philosophy, structural hints. ASRA Phase 2 is the project's shift from pixels to predicates. Objects as first-class citizens, transformations as typed events, rules as explicit hypotheses, with honesty about demo heterogeneity via branched models. The theory article specifies what is being built and why. The Kaggle notebook deploys compact object hints to ArcAGI3. Every testing layer, bootstrap, self-test, parquet gate, library tests, and scoring, validates the observation engine before competition. Transition-centric adaptive reasoning remains the core. Object-centric structure is how those transitions become understandable.